Welcome to Section 7.2, two proof-oriented triangle theorems. Our objective for today is to apply the no-choice theorem and the angle-angle side theorems when proving triangles congruent. For our homework, we're going to be working on page 304 to 306, 2 through 8 evens, and 14 to 18 evens. We have two theorems to begin. The no-choice theorem states if two angles of one triangle are congruent to two angles of a second triangle, then the third angles are congruent. And let's see how that works. Here's two triangles. And let's say we know that two of the angles are congruent. And if they're congruent, we know they have the same measures. Let's say this is 70, and its match is 70. Let's say this is 80, which means this angle is also 80. Congruent angles will always have the same measure. Well, let's find out what that third angle is. I know I'm going to add up my two angles, which is 150. I'm going to subtract it from 180, which leaves me with a 30-degree angle. Do the same thing over here. Well, we have the same angles, so when we add them, 70 plus 80 is 150. 180 minus 150 leaves me with another 30-degree angle. So if we know two of the angles are congruent, then we're going to know the third one. It's called the no-choice theorem. Our second theorem is the angle-angle side theorem. Now, we've already studied side, 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 angle, side, and angle, side, angle. This is actually another way to prove triangles are congruent. And it states if two angles in the non-included side of one triangle are congruent to two angles in the corresponding side of another triangle, the triangles are congruent. Now, we do have to be a little bit careful with this. So here's our two triangles. Let's say that these two angles are congruent. Let's kind of spin this around. Let's say these two angles are congruent. Now, let's say we know this side is marked on my first triangle. Now, the side that needs to be marked on my second triangle has to be the corresponding side, which means it needs to be in between the angle that has two tick marks and the angle with none, which would be this angle here. You have to make sure that the sides are corresponding. So the side could not be marked here, nor could it be marked here. They have to make sure that they're corresponding sides. Now, I know this excites you beyond belief, but we are going to be getting back into a little bit of proofs here. So here we go. Let's do our statement and our reason charts. And let's write in those givens. We know angle G is congruent to angle K. We know angle H is congruent to angle M. And we know JH is congruent to OM. Those are all given to me. Why would these triangles be congruent? Angle, angle, and just make sure it's corresponding sides, and they are. Triangle GHJ is congruent to triangle KMO by angle, angle, side. Easy peasy mac and cheesy, right? Alright, here's another one. Let's see if you can do this one on your own. Press pause, and let's get to it. Alright, here we go. We've got our statement and our reasons. We're only given one given. That angle A is congruent to angle D. It's given. I'm going to mark that in. Now, looking at this picture, I see that I have my bow ties, my vertical angles. Angle ABE is congruent to angle DBC because vertical angles are congruent. Now, we're trying to prove angle E is congruent to angle C. We're going to use our no-choice theorem that says if we know two angles of a triangle are congruent, we also know our third. Angle E is congruent to angle C. Our reason? It's no choice theorem. Again, nice and easy. Too good to be true with those easy proofs, right? Absolutely, we gotta challenge ourselves. So, here we go, a much more complex proof. We have a total of 5 givens, and in the end we want to prove that we have a rhombus. So let's press pause and let's see what we got. Okay, so far I have my givens listed, and I have my picture marked out. Now, if I'm trying to prove it's a rhombus, I have a bunch of different options. Most of my options require first knowing that I have a parallelogram. Do I have a parallelogram? Absolutely. I have both pairs of opposite angles are congruent. So let's start off there. We're going to say that TRPN is a parallelogram. For my reason, if both pairs of opposite angles are congruent, it's a parallelogram. Alright, let's see what else we got here. Now, a lot of us are going to want to use subtraction to get these two little angles congruent, but you know what? It's not going to work. I don't know anything about these little angles, or that my angles stop here with the overlap. So instead we have to go off the perpendiculars. So here we go. Since we have two different perpendiculars, we want two different sets of right angles. I'm going to say angle TON is a right angle. Definition of perpendicular. And I'm going to say angle TSR is a right angle. Definition of perpendicular. Then I'm going to go ahead and say they're congruent. Angle TON is congruent to angle TSR. All right angles congruent. Let's mark it in. Now, looking at my picture, I know triangles are congruent by angle, angle, side. Triangle TON is congruent to triangle TSR, angle, angle, side. Now, I want to prove that I have a rhombus. So I have to think about what CPCTCs are going to be best. Now, in a rhombus, one way we have is just to prove that all four sides are congruent. I don't see that happening really easily. How about you? So now we have another option. If I know that I have a parallelogram, and I know that one pair of consecutive sides is congruent, such as TN and TR, I also know it's a rhombus. So let's go ahead and I'm going to continue this on the side. For my CPCTC, TN is congruent to TR. As long as I know that I have one pair of consecutive sides, and I already know it's a parallelogram, which I got, I know that I'm going to end up with a rhombus. So I can say what I'm trying to prove. NPRT is a rhombus if one pair of consecutive sides of a parallelogram are congruent. It's a rhombus. And we're done. Here's the answers to our homework. Again, we had 2 through 8 evens and 14 to 18 evens. As you see, we have over half of them are going to be proofs. I promise you, this semester is not going to be proof heavy, but we will still have a little bit of proof sprinkled throughout. If you have any questions, make sure you ask them tomorrow, and as always, have a good one.